This tutorial shows how to create and bind escape rooms electronics. Close the bottom windows, they are useless now. Create new project. Press Create New Project button and select a folder, where your Queen project will be located. Specify the project name then, and select Initial Template. Let it be a base template. After you press OK button, Queen Studio will generate a project, and all file system structure. Base template tell Queen Studio to create a project with pre-installed components as you see. First, let's make a substrate as a building plan to place electronic components on it later. Copy plan.png to the Media, Image folder. This very important to keep all the files inside the project folder to have a project's integrity. This will ease a distributing release later, when you will copy your project to another PC. Click on the canvas, and select Push an Image button in the Properties window. Select the plan we previously placed to our image folder. This plan was purposed for the damned amulet escape room we automate in our tutorials. This file link is given to the video description. To remove a border between substrate image and background color, we can set this color to the same value. Now, the colors are identical. Let's go on. Place components. For example, place audio control here. Game control navigator place here. Set grid snapshot to a comfortable value. I used to with 5 pixels grid snapping. You can change object position and geometry as following. Let's name audio control as general. Because this audio will control escape room general sound. Let's begin with electronic control components. We can create these possible objects types. The first object type is called PWM. It is used for binding to Queen board transistors for the power smooth control, for example LED brightness control. The next object type is out. It is used for binding to Queen board relays in order to switch on or off any device. This is an analog input object type, is called AIN, is used for plugging any sensors. And the last object is DIN, mostly used for plugging buttons, switches, reeds and other devices with a dry contact. There is an extra object type, is called UNI. But we will discuss it later, in the future tutorials. So, we create one instance of each type electronic objects. And now, let's bind them to the real hardware. To implement this, we should create an object that describes this hardware. Create a board object. We assume the board could be any control board, but in our case this is a Queen board. Set type as a Queen board. Leave name as board 1, but you can specify any name you prefer. The main parameters are the own IP address and port, and the remote IP address and port. Own references to the computer where Game Manager will be running. In our case, this device is probably Raspberry Pi. Remote parameter references to the serial server as a Queen board Ethernet frontend. I try to explain how it works in details. Command for relays or transistor controls goes from the Raspberry Pi to the serial server via the Ethernet. Serial server converts these commands to the serial interface, 232 rupees or COM port, and send them to the Queen board. Queen board executes the commands, reads analog and digital input and send the answer via serial interface back to the serial server. Serial server converts it to the Ethernet and sends it back to the Raspberry Pi. These cycles repeat 10 times in a second and provide high-frequency real-time session between the software and the hardware. Queen Pack hardware has the default, pre-installed setting as following. Serial server IP address and port settings. Raspberry Pi IP address and port settings. Board parameters were set up. Let's go on with electronics. Imagine, we have a LED strip plugged to the first transistor, electromagnetic lock plugged to the first relay, lighting sensor plugged to the second analog input, and a limit switch plugged to the third digital input. Let's check if everything binded right. Perfect. Now we will start our escape room model in real mode. Button Start Queen Room on localhost executes an application, but it substitutes IP addresses to the local host as you see on the screen. This allows to establish connection with Queen Board emulator running on the local host too, instead of real Queen Board hardware. Let's check it out by running Queen Board emulator and running Queen Room. As you see, the connection is established. If I close an emulator, we see the disconnection. We have just emulated a Queen Board power off. Let's start emulator again. If we change the PWM component value, the emulator reacts, and if the real LED was plugged to the transistor, the brightness should be slowly grow up. The maximum value is 255, the minimum value is 0. If we click on the out component, the emulator reacts, and if the real electromagnetic lock was to the relay, lock should be activated. PWM and out components are output components. Queen Room change its state, Queen Board or emulator reacts. As for analog and digital inputs, we have a inverse logic. We change value in the emulator, and Queen Room must indicate these changes. Let's check it out and emulate. Photoresistor detects slow light switching on. As we see, Queen Room indicates the changes. What does this mean? Analog output has minimum value 0 for 0 input volts, and maximum 1023 for 5 input volts. And the last component is a digital input, and if we emulate a triggering, we see Queen Room detects changes. So, using the Queen Studio and emulator, we can set up our escape room at home on the laptop, and it should work absolutely identical on the real hardware like Queen Board. Next tutorial we will bind all the electronic for our escape room, damned amulet.